just to back up for a second, we have to know where in the semester this is from, right? So the order of this differential equation, right? The order is so crucial. If it's first order, like that problem, of course you're doing chapter 1 stuff. Suddenly now, though, this is chapter 6 material, because the order of the differential equation is 2. So what I have to do here is write down the auxiliary equation first, right? Which would be what for this problem? R squared plus 9 equals 0. Okay, and do we know the roots for this? Plus or minus 3i, guys, that's a very simple step. I'm going through it very quickly, but you have to get that right. Okay, it's plus and minus 3i. Based on that, what can I do next? Eduardo, what's my complementary function going to be?
E to 3x times cosine 3x plus e to 3x times sine 3x.
Anybody have any problem with any of that?
Oh, yeah.
First of all, we need to have constants in here. And what else? This is r equals 0 plus or minus 3i. So what should I be taking off of here? Right? There's no exponentials here, right? So it's just, this is really what you should have right here. Okay, so c1 times the cosine of 3x plus c2 times the sine of 3x. Okay? Okay, so that's my complementary function. What's the next step after I have the complementary function? Sorry, I don't like that answer too much yet. But you're getting ahead of me.
Find a particular solution.
Yeah, I need to find a particular solution to the equation. Thank you. That's step 2, right? Step 2 is always we need to find y sub p of x. So we're reviewing some of the more recent material here. And when I'm thinking about particular solutions, what do I have to decide at this point?
Annihilator versus variation of parameters.
I have to decide whether I'm going to use the annihilator method or whether I'm going to use the variation of parameters method. Those are the only two methods that I taught you guys, so it's got to be one of those. Which method would you suggest I use here?
Variation of parameters.
Yeah, I'm going to use variation of parameters, and why is that the right method?
No, annihilators.
Yeah, we don't have a good annihilator. You'll have the table of annihilators, obviously I don't have it with me right now, but the table of annihilators doesn't have secant cube in it. If you're wondering what's on the table of annihilators, just so you know, I posted the, you go to my website, and it's linked there, so you can go through and see exactly which things are in the table. But secant cubed is not in that table. So we're not going to be able to annihilate the right-hand side, and it's only a second-order differential equation. We know how to do variation of parameters for that. Okay, so if I'm going to use variation of parameters, now I'm ready to hear how to proceed with that method. What would I do first? Yeah, I like to find the Wronskian first. Okay, so to do the Wronskian, I need to have my functions identified from the original complementary function. So those are y1 and y2. Does everybody remember how to do the Wronskian? Okay, it's basically the Wronskian of y1 and y2. I'm going to do it quickly. It's the determinant of, we put our two functions on the top two lines of the, or on the top line of the matrix. And then we just take derivatives down the matrix. So negative 3 sine of 3x goes here, and 3 cosine of 3x goes here. Okay? So if you work that out, what do you wonder, what's the question you have about the determinant? Is it 0 always, right? Or can it be made non-zero at some point? If there's even one value of x that makes it non-zero, then you're, well, of course, then that just means these two functions are linearly independent. Of course, they clearly are, because there's just two of them and they're not multiples of each other. But we also need this Wronskian because it goes in the formula for the particular solution. Remember the formula, u1y1 plus u2y2 and the U1 and the U2, we have to have these formulas down, right? They both involve integration. U1 is negative the integral of y2f over the Wronskian, and U2 is the integral of y1f over the Wronskian. Alright, so what is this determinant equal to?
3.
Everybody get 3? Should just be 3. Okay, so that's easy enough. So then we just have to go through and work this out. So U1 would be negative the integral of, I take y2, which was the sine of 3x, I multiply it by f, which is 18 secant cubed of 3x, and I divide it by my Wronskian, which is 3. Okay. So the 18 and the 3, of course, makes 6. I can pull that out in front. So it's negative 6 times the integral of sine of 3x, I'll write it this way, sine of 3x over cosine cubed of 3x. Just do it like that, maybe. Any ideas on how to integrate that, by the way? Yeah, I would do a substitution, a u substitution here. What would be your choice for the u?
Sine of 3x. Or cosine.
Cosine of 3x would be a better choice. The denominator then is u cubed, right? And then the derivative of this is negative 3 sine of 3x dx. So the dx, so when I do the substitution, I'm actually going to put it in to make sure I don't rush too much. The dx gets replaced, well, the sine 3x dx gets replaced with du over negative 3. So I'm going to put the over negative 3 out in front. And then this becomes 1 over u cubed. So this becomes 2, 6 over 3 is 2, and then this is the integral of u to the negative 3, which would be u to the negative 2 divided by negative 2. And then we don't need a plus c on this, right? We don't need plus c because we're doing a particular solution. So this just becomes negative of u to the negative 2, so that's just negative of secant squared of 3x. See, the u squared is cosine squared of 3x, but it would be on the bottom because it's a negative exponent here. So instead of writing it as 1 over cosine squared of 3x, I'm choosing to just write it as secant squared of 3x. And then there's a minus sign on that. So it took a little bit of work to get that integral. Let me just make sure I'm happy with that. Does that look okay to everybody? Okay, so negative secant squared of 3x, I guess that's right. Interesting, because it's not what I have in my answers. I have negative tangent squared of 3x. That might be a mistake. Oh, I know. So this is what I just came up with right here. In my solutions, when you look at my solutions, I have this written down. And guess what? They're both right. And the reason that they're both right is because 1 plus tangent squared of theta, there's a trig identity that says that, right? So the difference between my answer right now and my answer in my review packet is a -1. Is like a plus c, right? Plus c doesn't matter in the context of finding one specific solution. You don't have to worry about changing it by a constant. So this answer is perfectly fine, and so is the one that's in the solution packet. If they're off by a constant from each other, we're all good. I mean, after all, you could take this answer and say, you know what, I want to put what would it be? A +1 on the end of it, plus c, right? And choose c equal to 1. You'd have that choice if you wanted to. Well, the minute you do that, 1 minus the secant squared becomes the tangent squared. Right? So yeah, so anyway, not a big deal. Not a big deal. So I'll just leave it with what I came up with here. All right, then we have to do the U2 as well. I'll try to do this quickly. We have to do U2 as well. U2 is the integral of y1 f over w. So we have y1 was cosine of 3x. Then we have 18 secant cubed of 3x, that's f, and then over 3. So as before, 18 over 3 is just 6. This time, cosine and secant are reciprocals. They actually will cancel one another, leaving me only with secant squared, right? Secant squared of 3x dx. Anybody happen to know how you integrate secant squared of theta? It's actually a simple, the derivative of secant is secant times tangent. So does anybody know a function that has whose derivative is secant squared? It's tangent of theta. This will be in the table of integrals. You'll see it there. So the point is that this is basically the tangent of 3x. If you take the derivative of tangent of 3x, you're going to get secant squared of 3x times 3. So I'm going to divide by 3 right here to adjust for that. So yeah, the derivative of this will be that. And again, I'm going to leave off the plus c. So this becomes 2 times the tangent of 3x. All right with that? So my particular solution then, ready to write down how that's going to look, is going to be u1, which was negative secant squared of 3x, times y1, which was cosine of 3x, plus u2, which is 2 tangent of 3x, times y2, which is sine of 3x. That's it. That is the particular solution. And so my final answer then, my final answer for y of x would be c1 times the cosine of 3x plus c2 times the sine of 3x. That's the complementary function that we found earlier, right? Plus this. So minus secant squared of 3x times cosine of 3x. I guess that could have been simplified as well. And then plus 2 tangent 3x, sine of 3x. There we go. That's my final answer. Looking all right? Okay, great. Any questions on that? So I'm not spending a lot of time today on chapter 6. It was just covered on the last midterm, so you guys are going to have to go back on your own and remember how to do annihilators and some of that kind of thing, or review this a little bit more. Just feel like maybe it doesn't need as much attention right now as some of the other stuff. So, all right, let me just see where I'm at. I've done all 3 of those. I've done that one, and that one. Okay. Oh, and I've done that one too. Okay, so I am doing pretty well. I think we need to talk about inner product stuff a little bit. That might be a good thing to go into. So, let's practice some inner product stuff. Am I on number 7? Okay. All right, number 7. So here we go. So here's what it says. State the inner product axioms. And decide if, and here's the formula, the inner product, I'm going to take two functions f and g, so decide whether this inner product, so I'm going to integrate from 0 to 1, of t, f of t, g of t, dt, is a valid inner product. This is part A. Part A. So, state the inner product axioms. Does everybody remember how many of them there are? Yeah, there are 4 inner product axioms. So we basically have to write them down and then check them. This inner product that I gave you is basically an inner product on the set of calculus functions. F and G are like functions that you're going to integrate here. Normally, the inner product that we use doesn't have that t in there. As long as the t is not in there, everything's good. For any limits a and b of that integral, everything works out great. So the real question for today is I've tweaked it up just slightly. I'm putting a t in here. So then the question is going to be, does it still work? Okay. But before we get ahead of ourselves, we need to write down the axioms. So can anybody remind me what the inner product axioms are? Justin's got one of them anyway.
The first one is the inner product of f with f is greater than 0.
Can I just do it, I'm sorry to interrupt you, can I just do like the general notation? So the inner product, I would just use the variables of the vector v. Okay, so whenever I take the inner product of a vector with itself, what has to happen?
It has to be greater than or equal to 0, but only 0 is 0.
Okay, so did everybody catch that? Basically, the inner product of a vector with itself has to be positive. It's allowed to be 0, but only if it's the 0 vector, which you started with. Be careful to remember, guys, that what we have here is not like a vector in R2, right? This is a notation. These angled brackets are just a notation for the inner product, and this is a number. When you calculate the inner product of two things, you get a number. So this number has to be at least 0. All right, so that's the first thing. Okay, can somebody else tell me the second axiom? Hold on. Jocelyn.
The inner product of k times b.
K times v, okay.
With the different.
W?
And then the k comes out to the front.
Right, okay, so I can pull the k outside. Okay, so the k factors out. Now, if you have a k in both slots, then if you want to pull the k out, it actually comes out twice, right? So it would be actually a k squared. So this is only pulling the k out of one of the two entries. Okay, can somebody give me another axiom?
V1 plus V2
Okay.
times W
Yeah, just use whatever letter you want. Okay, W, good.
is equal to V1 plus W. V1 plus W.
No.
Inner product of V1W plus inner product of V2W.
That's it. There we go. Okay, so it respects addition, basically. I think I put this on the midterm. I gave you a linear transformation that was defined by taking the inner product, and so you actually had to check this to check that it respects addition. Okay, that's exactly right. So this number has to equal this number plus this number. Okay, that sounds good. And there is one more axiom. Does anybody know what it is? You'll know 2 days from now, right? For sure you want to know these axioms. So the last one is that the inner product of v with w is the same as the inner product of w with v. You can switch the order. Right. First slot and second slot, those can be switched around. Okay, so those are the 4 axioms of an inner product. And I might very well ask you to write some or all of them down and then check them on an example. So that's kind of what we're doing right now on this problem. Okay? Okay, so let's see if we can figure out if this is this particular inner product satisfies all of these 4 rules. Let's give it a shot, okay? So let's just check out the first one. Remember that when something fails to be a valid inner product, it usually is the first one that doesn't work. So I'm hoping that after we do the first one, we'll have a good idea whether it's going to work or not. And of course, if we find an axiom that fails, we can stop. We don't have to go on to the other ones, right? We just check the one. If one thing fails, then it's basically game over at that point, right? So let's check this here. So inner product of f with itself. Just using the formula up there is going to be what? Anybody? What's the inner product of f with itself? Integral from 0 to 1 of t, not t squared, just t, times f of t times f of t, which is just f of t squared. Yeah. It just looks like that. Okay. And the question is that greater than or equal to 0? Why?
Because anything squared is always going to be a positive number.
Okay, so f of t squared is positive. Okay, is that all you have to say? You're integrating from 0 to 1, so the value of t is going between 0 and 1, which means it is also positive, right? So this whole thing, basically this whole thing is greater than 0. And you're integrating it. It's like having a function that's always above the x-axis and you're doing the integral. Of course you're going to get positive area under that graph, right? That's what the integral represents. So this is greater than or equal to 0 since t times f of t squared is greater than or equal to 0 on the interval 0 to 1. Okay? Does that make sense? People okay with that? Just as a, well, maybe I'll come back. I'll come to my other point in a second. The other thing is, the only way that this could equal 0 is if f of t was 0. Because if f of t is not 0, then when you square it, you're going to get a positive amount. Multiplying it by a positive amount, the whole thing is going to add up to a positive amount, right? So this is equal to 0 only when f of t is equal to 0. So the first axiom here, the first axiom is checking out nicely. It works. Okay? Let's try another example. Let's try another axiom. Let's try the one about the constant. Is that one going to work? If I take k times f, inner product with g, let's just run through the formula. Let's just run it through the equation there. So it's just the integral from 0 to 1. T is my variable. It's always going to be in there. F of t is now kf of t, and then g of t, and then dt. So what are you going to do with that? Yeah, kf of t is just k times f of t. And k being that it's a constant can be totally factored out. Exactly. So we're just going to pull it straight out. It's k times the integral from 0 to 1 of t, f of t, g of t, and that then is just k times the inner product of f with g. Exactly. Go straight to that step right there. So far so good? Alright, so that's easy. Let's try the third one. The third one I have to have 3 vectors for. So I have to use like f, g, and h. Let me do like f plus h, inner product with g. So this is we want to see if we can break it up. So this is the integral from 0 to 1 of t times f plus h of t times g of t dt. And what can I do with that? If anything. Yeah, this part right here, f plus h of t, is really just the expression f of t plus h of t. Right? So this then becomes the integral from 0 to 1 of t times f of t plus h of t times g of t dt. Go ahead and erase these for now. I think we've got them down. And now what do you want me to do with that? Split this up, right? Split it into two parts. This is just the integral from 0 to 1 of t f of t g of t dt plus the integral from 0 to 1 of t h of t g of t. And that is the inner product of f with g plus the inner product of h with g. So there's the way you can write that up. So it does work. Third axiom is also working. What do you think about the fourth axiom? Is that going to work? The fourth axiom is the inner product of f with g compared with the inner product of g with f. Will they be the same? Absolutely. You can just look here. If you switch where the f and the g are, at the end of the day, the integrand is still the same. Okay, so this one is very short. Basically, you just write down the formula. Integral from 0 to 1 of t, f of t, g of t. And then you just simply, what you would want to do, what you'd want to write down to show me, is just switching the positions of the g and the f. Okay, so the g comes in front of the f, and then you just go back to the inner product notation again. So actually, this works. This is actually a valid inner product. It's a valid inner product. We checked all 4 axioms. I might not ask you to check all 4 on the test, but I might say, oh, write down 2 of them and check those 2, or something like that. Yeah, Ashley?
So for the test, the part of the interval will change, right? That's what you would change if you were changing problems?
I don't have any idea what I would do.
Well, but I'm saying, like, if you want to see a different problem, it's just basically the...
I could change that t to something else, sure. Actually, there's a bunch of things I could do. Actually, let me ask you this question. So, based on what we've done so far, would this work? Just a side question here. What if I change it to the inner product of f with g is the integral from -1 to 0 of t, f of t, g of t, dt? Does that work?
No.
Definitely not. And you see what the problem is? Yeah, the first axiom, which is usually the one that doesn't work, is going to give you a negative number, isn't it? Because now this t, right, is running through a negative part of the x-axis. F of t squared is still positive, right? This part is positive, but the t flips the sign of the integrand, and you end up getting a negative answer there. So that would be one way to change. So I can change the limits of integration as well. Give you something to think about on that. So, but anyway, so this one does work. So therefore, since it's an inner product, now of course I have a part B to the question, because we can use the inner product now to answer some other questions. So let me give you part B of this. Part B says, find cosine of theta where